Today we'll continue whatever we left, like where we left from yesterday for backtracking questions. So yesterday I was able to cover the subset, combination sum, combinations, and let's see permutations, and then we can go over um, to the variations of these four top questions. Let's see those. Okay. So if you guys remember that, let me rephrase. So yesterday we saw how we can found the base foundation for the permutations. So today we'll try to see and implement that on this particular this particular question, that is permutations. So the question says, given an array nums of distinct integer, return all possible permutations. You can return the answer in any order. So the order is 1, 2, 3, and we have to return basically the permutations of it. Okay, I understand that. So again, the similar thing, we have to return basically that result array. But now in this case, the challenge is that we have to, I guess we'll need a for loop for this, because all we have to do is like start traversing it from the initial path. Yeah, that's what we have to do. And once we reach the end of the loop, then we can probably, yeah, then we can store it in the result array. But I'm just thinking, how on earth can how can we do it like iterative fashion, like not iterative fashion, but not using a for loop? Because if we start from the 0th index, yeah, so I guess we might end up taking the for loop, for that matter of fact, because yeah, we might end up taking the for loop. So yes, yesterday in the morning session we also did this question, but I'm not sure if I you know created a tree or anything of that sort. Let me minimize this. Okay, so I'll just let the chat know that I won't be able to chat today. I'll be just focusing on uh, solving questions. Yeah, that's what we'll do. Completely focused on our task. I want this session to be as productive as possible. Okay guys, let's do this. I'm just refreshing my Miro board so that I can delete all of the unnecessary things from this board. Okay, so I have the Miro board with me and I'll just delete that. Okay, deleted. Okay, cool. So once we have deleted that, we can simply go, and what was the array that was given to us? It was 1, 2, 3. Okay, let me bring that to center so that we can expand from here. So looks like we have to create permutations, right? So all that we have to do here is that we have to basically have an empty array, right? So we start with an empty array as always, but in this case we can take three paths, like we can take either one, we can take two, and we can take three. So what we'll do is so that's where the for loop will come. The for loop will traverse these three guys, and we yeah, that's what we'll be doing. So these three elements will always get an empty array. I'll let you know how that will happen, but yeah, I'm just trying to understand myself how this is happening, so my foundation is solid moving forward to other questions. So yeah, we have to actually for loop because this is a permutation question, and we have to pause permutation question, and we have to find uh, all possible combinations, right? So we have an empty array, and what we do is we can go to three loops on three, but the for loop is first one. So what we'll do is we'll add one, we'll see the first zeroth index, right? I'll also specify the indexes. So when we traverse to the zeroth index, what we'll do is we'll add one, and from here what we can do is we can uh, traverse more three paths, right? Every time we have to traverse more three paths, so that we can take all the permutations, and as all the elements are distinct, we can also check if the current element is already added to the array. So yeah, what we'll do is we'll again go to 0, but if we go to 0 we see that it's already added. Then we go to index 1, which adds 1 and 2, and from here we can again go to three paths. So 0 and 1, this is already added, so the index 2, whatever the element on index 2 is not there, so we add that 1 2 3. So we get one of our answer. Okay, so here we have to stop. So base condition would be what? When basically uh, my temporary array reaches the length of the nums, then I have to stop basically and add whatever I have gathered till that point. I have to add to the result array. So that is that, and then basically after adding that we will return back, and there is nothing else to be traversed from this place, so we'll again return back, and yeah, once we return back, we'll see, yeah, from here also we'll return back, and then we'll see that there is one more path that needs to be explored, which is of 2, index 2. So yeah, we see that, and we add 1 comma 3. So we backtracked, right? So we pop the element essentially, and then pop the added 2, and then we backtracked. So 1 and 3 is there, and from 1 and 3 we can again go to three paths. So 0 is already there, the item on index 0 is there, 1 is not there, so I can take 1 3 2. This is one combination that we found, and here then we return back, and then 2 is already explored, 2 is already there in the array, so in the temporary array here. So yeah, we don't do anything about that. Okay, cool. So we again return back. So looks like we have we return. So from here let me show it with, we return back to here, and from here we return back to here, and we see that all the paths have been explored from this point, so we also return it from here. Then we go to the topmost guy, and we, while backtracking, we always remove the element. So that's why we'll get an empty array, and for the um, next loop that we have, that will start with an empty array which is 2, and then again we can take 3 paths and follow the same process for this one. Yeah, hopefully that there's no not much going on here. So what I'll do is basically create result is equal to an empty array, right? And let's expand this guy, and then okay, let's do this. So backtrack, we have to backtrack, right? Backtrack, and all we have is an empty array initially, and then we have to return this result, and we have this function backtrack and the temporary variable. So our only condition would be if the temp dot length equals to what, the nums dot length, then we know for sure that we have reached the end, and we can just add result dot push all the temp in there. So yeah, once we have done with that, then we have to basically loop through ch. So num of nums, let's do that, and if temp includes nums, then continue. We don't want to do anything there, but yeah, if temp does not includes the number, then we will push it we'll push the num, and then we'll call backtrack on it, so that we can see all the paths from there, and whatever we can gather, we'll see that. We'll pass the temp, and finally before going to the next loop, we want to give the same state to the next guy as well. So that's why we pop it here. Yep. So yeah, that is what it is, and basically I guess I am not doing anything foolish. Yep. So if I run this, is it going out? Time exceeded. Okay, let me see what's happening. Oh, okay, I did not return from here. I'm really sorry about that. Okay, so but I'm if temp dot includes num, oh, num, it is num, sorry. Now yeah, so this works, right? And let's submit this. Okay, so that is cool, and the time complexity for this one is uh, uh, in terms of permutation, we are always doing n factorial. Let us go to the board and see why it is saying n factorial. For 3, for the length 3, so 3 n factorial, right? So let's read the read why the yesterday I did not read the why the time complexity was derived like that. So today we'll read why the time complexity is like that. Finding permutation is a well-studied problem in combinatorics. Given a set of length n, the number of permutations is n factorial. N, yeah. There are n options for the first number, n minus 1 for the second, and so on. Okay. For each of the n permutation, we need of n work to copy. Yeah, that is true. N into n factorial. The analysis used to derive this time complexity is way out of scope for an interview. We have included it for the sake of the completeness. In an interview, you can use explanation above while explaining that it is an approximation, and then mention that the true time complexity would involve calculating the number of nodes in a tree, which is very difficult to do analytically. Thus, the number of nodes in tree is equal to the number of k permutations, where k is the range of 1 to n. The number of permutation can be calculated using this formula. Okay. So let's leave it at that. Let's not go in depth and blow our minds with the mathematical equations that are going on there. Um, I it might be easy for someone of you, but I'll just keep it as is, and let's try to build the foundation from here and go to some other questions and try to solve them. Okay, let's do that. So we have seen permutations. Let's do subsets too. Okay. I've also done that, but I'll try to do that again. Okay. And my today's goal would be from, not from this list, but from this list. I want to actually reach n queens. I want to do n queens. Yeah, I always wanted to do n queens, and hopefully if I do these many questions, I'll get a better understanding of how n queens is working. Yep. So let's do this. So subsets 2. What I have here is, given an integer array nums that may contain duplicates, return all possible subsets. The power set. The solution set must not contain duplicate sets. Return the solution in any order. Okay, so given an integer array nums that may contain duplicates, return all possible subsets. Okay, we have to always, in subsets, we have to always keep moving forward. That I know. Okay. So looks like the solution set must not contain duplicate sets. Return the solution in any order. Okay, so I have 1, 1, 2, okay, 1, 2, 1, 2, 2, and 2, 2, 2. Okay, so in this case, where is the duplicate happening? 1, 2, 1, 1, 2, 1, 2, 2, 2, and 2, 2. So let's see, let's add a test case here. I'm thinking if I add, so given an integer array nums that may contain duplicates, return all possible sets. The solution set must not contain duplicate subset return. So I'm not sure if this is sorted at all, or I'm not sure about that. So I would definitely ask the interviewer if this guy is sorted. If not, then I assume that this could happen. This thing could happen, right? Like 1 1. Let's see if this works. Like what answer does it give? Okay, yeah. So it gave answer like 1 1 1 1 1 2 1 1 2 2 and 1 2. Okay, this is interesting. So how will I make sure that the same thing is not created again? Because here there are duplicates, right? Okay, now this is getting interesting. Cool. So given an integer array that may contain duplicates, return all possible subsets. The power set, the solution set must not contain duplicate sets. Return the solution in order. So okay, let's try to build how this would go. Let's try to see what can we build with this one. Okay, it's again out of sync, so let me sync it back. Okay, so we have 1 2 2, right? We have 1 2 2. We want to create subsets of this, so the answer looks like an empty array 1, then 1 2 1 2 2, then 2, then 2 2, right? This is what it's looking like. So this looks more or less like the first subset that we have solved, but now the slight variation is that there might be duplicates. In the first thing there was just there were just distinct elements, and we can be rest assured that none of them would be repeating. But now that the table has rotated, I guess. Okay, so what can we do? So here if you see this guy, which was the later one that we added, 1 2 1 2, so the subset answer for this one, I'll just write it down just for comparison's sake. It has 1, it has 1 1, it has 1 1 2, it has 1 1 2 2, it has 1 2, and it has 1 2 2, and it has 2 and 2 2. Okay, so if you let me bring that board again. So if you see that it starts with an empty, then 1 1 1 1 1 2 1 1 1 2 1 1 2 and 1 2 2. Yeah, so it's going like that. I guess what we have to do is before even moving to solve this one, I guess I have to sort this array. Yeah, if I sort this array, then it will look like 1 1 2 2, right? it will look like this. And and then what I can do is, so I'm thinking, when we are traversing the tree, then when we are traversing the tree, we I need to keep track of my previous node, so that I won't traverse the same, yeah, using the same number again. I won't traverse to the different branches. Okay, let's first figure out how not doing that will affect and what will it get us. Okay, I'm not worrying about the duplicates happening, and let's see how will it affect us. So I will just use the same strategy that we have been using for subset question, and let's see how that works. And yeah, okay, cool. I'll do that. So we have an empty array. We always starts with an empty array, and yeah, we are at index 0. So we have 0, 1, 2, 3. If you see, yeah, I hope that it is not looking messy. So yeah, let's go forward from here. So I'm on 0, right? So either I can take 0 or leave 0, right? That's what we did. So I take this 0, I added 1. Now we can go to 1, 1. We can take 1 or leave 1. So we add 1, 1, and we leave 1. Okay, and from this point we can either take 2 or leave 2. So if we take 2, this will be the answer. Okay, and if we leave 2, 1, 1 would stay the same. And then again, if I go ahead, 3 would be there. So 1, 1, 2, 2, and if I don't take it, 1, 1, 2 would remain like as is, and this cannot be further traversed, and this guy also cannot be further traversed. Okay, so yeah, these two looks like to be the answer, like one of the answer sets. Yeah, if you see here, this is one answer, and this is one of the answers, right? So we've got two of them here, and then we'll backtrack, and once we backtrack, we'll get this, and there is nothing else to be traversed from here. So we'll again backtrack, and then we go to this guy, this path, and then we can, from here we can either take 3 or leave 3. So if we take 3, 1, 1, 1, 1, 2, and here just 1, 1 is there. But if you see, we have already gotten 1, 1, 2 into our result set. So this is a duplicate, right? This is a matter of duplication. So what if we do like this? What if we create a set? Like, anyways, we are getting everything, right? So what if we create a set, and for that set we'll add whatever value we have gotten till that point. We'll take that, we'll add it to the set, and yeah, like hopefully say that if we see this again, then don't add it to the result set, or else add it. We can do that and return back. So that would be one of the way of doing this. Yep, that's what I'm thinking. So sorting it and using set would be one option. Okay, but if we are smart, then how would we try to avoid this? Okay, like, is there a smart way of avoiding this? I'm just thinking, like, if I see a next variable that is just same as what we saw earlier, then we don't want to proceed ahead, right? I'm thinking in that term, but that way, but looks like so what I was thinking is, if I take one, then if my next item is equal to the previous item, then I'll leave it. But I cannot do that, right? I cannot do that in this case. So I guess using set would be a better option. So yeah, that's what I'll do. I'll use a set, and hopefully we can avoid use a set or a map. Yeah, we can use a set or a map, and then hopefully we can say that we have seen this already and we don't want this anymore. So yeah, let us use a map dot new map. Okay, so and we have to also have a result, and then we need to basically return that result back, and we need to also backtrack using that empty array, and then function backtrack is equal to temp. Let's call it temp. Okay, so once we are here, what we can do is what we can so the base condition of ours was if temp, and we also want to start with an index, right? So that would be 0, and yeah, let's give it an index here. What we want to do next is if temp is temp dot length is equal to oh sorry, not the temp length. Yeah, when our index basically reaches to the last, sorry, my bad, I was just in the flow of previous question might be. So I'm just looking at the whiteboard and blackboard, and saw that once we reach to the index, then only we are like kind of doing the operation of storing the temp into the result. If temp is equal to what do you say, what do you call it, is equal to nums dot length, at that point I know that I have reached the end, and I want to basically add this guy. Whatever I have gathered so far, I have to add that back to result. But before doing that, I need to check if map dot has that temp. So how should I be storing that? I am not sure. Like let's say if I create, let me zoom this a bit for you guys. Let map is equal to new map. Okay, if I have this, and map dot set, if I add array 1, okay, so map dot has each okay, yeah, that will be false then. Okay, so what if I do let set is equal to new set, and what if I do this set dot add an array. Okay, set dot has false. Okay, every array is looking like it has its own reference. So how can we do that? How can the only option might be to convert that to a string. Okay, how to store an array as tuple in JavaScript set. What are they doing here? So understand that array is a reference, like every array is a unique, like whatever we are creating, that will be unique in its own way. Is there any other way that I can possibly store this? Yeah, what I can do is I can yeah, possibly create a string out of this, and then okay, let's do that. If let str is equal to, that would be an overkill, I know, but temp dot join, if I make this a string, and if map dot has str, then I want to return, I don't want to add this, else map dot set str, and what I want to do is result dot push, I want to add the temp to this guy and then return. Okay, so that's what I'll do, or else we will be doing the basic operation that we have been doing so far, nums of index, adding nums dot index, then backtracking on it, backtrack index plus 1, then temp, send temp, and then temp dot pop, basically pop that, and then again backtrack on index plus 1 and temp. Okay, that's what my mind is saying that would be a better option right now, like intuitive approach. Oh, we didn't sort it right. We didn't sort the nums. Nums dot sort a comma b, a minus b. Okay, now it's working. So if I run this should work. Cool. So it worked, but I think this is really like I'm doing n log n plus n into 2 raised to n. That's what I'm doing, like that's what the time complexity is. Let me just check like the other submissions that I've done. I might have seen this. Okay. Okay, yeah, looks like there is a smarter way of doing this. Subset.pop, when subset.pop is there, while we are pointing at the same thing, we move our indexes to the next one. Yep. I guess that would be a better way of doing this, but yeah, this would be a brute force approach of doing things, because we are having O of like how many ever subsets we can form, that many mappings we are storing. Mm, yeah. So I'm feeling hungry, guys. So what I'll do is I'll stop right here. So what we were able to do in this stream was looked at permutation and then subset 2. Like we were not able to look at the subset 2 in depth, but at least we scratched the surface. And okay, so that is looking good, and we can hop back onto solving these questions once I'm back from having breakfast. Cool. And thank you so much, guys, for tuning in. uh, yeah, see you in the next stream. Bye bye, take care.